Hello everyone. Welcome to 360 Degree TMG and welcome to the internet preparation session. So let's start. Okay. So what is text mining? What is text mining? So text mining is referred to as what is text mining? So it is referred to as text data mining. Okay, it's nothing but we can say roughly it's equivalent to text analytics. So what is this process all about? It is a process of deriving high quality information from the text. We don't want all the what is the information. We want the high quality information from the text. So how it is derived? It is derived from patterns, right? You devise the pattern, trends through some statistical pattern learning techniques. So text mining, it usually involves the process of you structuring the input text, usually parsing along with the addition of some derived, what you can call as linguistic features and removal of all others. And then we can insert that into the database. So deriving patterns within the structured data, and finally we evaluate, right? And we have to interpret the output, interpretation of the output. So when we say high quality here, high quality in the text mining, it refers to some interest associated with the information. So we have many things to do with text mining, right? Like text categorization, text clustering, concept, entity extraction, or sentiment analysis, document summarization, right? Entity relationship modeling. All these are a part of our text mining. There could be many sources, and very important these days, right, that we have different sources here coming up for our collection of data. Source of data collection, we can say, right? So it could be, first one could be maybe customer support information, right? Technical support, right? You have your emails, you have your ads, marketing things here, right? Maybe human resources available. And all this you can perform text mining. These are your sources of data here, right? That's why it's very important for us to do some mining on the data. Okay, next. So what is information? Okay, extraction. What is information extraction? Yeah. So it's nothing but a task, right? Automatically you are extracting the structured information, right? From unstructured, or it could be semi-structured, right? Maybe we can say semi-structured means machine readable kind of documents. So in most of the cases, this activity, it concerns like a process of human language text. So using NLP, that is your natural language processing, right? Natural language processing. So this depends upon the name entity recognition, which is your NER, a subtool I can say. It is used to find the targeted information to extract. So this NER recognizes the entities, right? First, as one of the several categories, maybe we can say location, person, organization. Once the information category is recognized, information extraction should start. It extracts the named entities related information and will construct a machine readable doc. Then the process of algorithm, the next process, like it will further process, algorithm will further process to extract the meaning. So this information extraction, it finds meaning by the way of other subtasks, right? Maybe we can say relationship extraction, language, or vocabulary analysis. Sometimes this can also happen with audio extraction, right? So unstructured format could be anything. You write very, very small sentence or a big sentence with the smileys, with double quotes, numbers, anything. So the structured information should directly be there for us to pull the information there, right? This is a your information extraction. Okay, what is text generation then? What is text generation? Generation of the text. So it is a type of your what we can say language modeling problem. So this is a problem what we have, whatever we the problem for several NLP tasks, right? Whether it is your speech to text, conversational system, or whether it is summarization of text. Okay? So the trained language models, they learn the likelihood of occurrence of the words based on your the previous sequence of the words, whatever they have been used in the text, right? So the language models can be operated at the character level. It could be n-gram level, or it could be even paragraph level, right? So it's nothing but a probability distribution over a sequence of words. It is also used to estimate your conditional probability of the next word which is going to come in the sequence, right? Like you have an encoder with your neural networks, recurrent neural networks, and you have a decoder also for the same. You have the target sentence, you have the source sentence. The next word should be predicted here, right? Okay. So what else we can understand from text data? What are the things which are important? Actually, what is NLP, friends? NLP, natural language processing, right? Everyone know that. Okay, what it is actually, why we want to focus on this particular concept, right? So, actually we can say that it comprises of what we have to understand, how we have to interpret, how we have to manipulate the human language, right? So if someone who is new, or he doesn't know that, anyway we have that onion peel diagram, right? What is AI, what is ML, what is data science, and all that. If you take some kind of what is deep learning, all finally we are building our AI driven product. So in that only we are interested in ML. In that only we have a sub concept, deep learning concept. The combination, I can say, of all these is our NLP, isn't it? Artificial intelligence, machine learning, NLP, deep learning. It's a combi, right? So when it could be anything, yes, speech, it could be text, it could be anything, right? So NLP, it includes your computational linguistics, right? And also its main aim is to fill the gap between the human communication and the computer understanding, right? So this uses very, very rich libraries, NLTK, TextBlob, it uses Core NLP, GenSim, Scikit-learn. I think we have Megatron library also, right? Which is coming into limelight these days. This is what actually we are filling up the space here in NLP. Okay, but do you have something to understand with the NLG, natural language generation? Do you have anything to understand with that? So it's a part of AI, right? Natural language generation is a part of AI. Yeah. What is NLG? Natural language generation. NLG is natural language understanding. So generation is nothing but you're part of AI, right? It will generate natural language text from your structured data to give an output. So where NLP is used to understand and interpret the natural language to form the data, and NLU is used to generate outputs in natural language from structured data. There holds a difference there. Okay. Now, I think this is known to everyone, right? Tokenization. What do you understand by tokenization? What do you understand by tokenization? Yeah. What we are doing, we are breaking your sentence into, or we can say it's a process, or it is an act. We are breaking a sequence of strings into pieces, right? And also, we can say that it is a word, or it is a phrase, or it is a keywords, or and any other element you call them as tokens. Tokens can be whatever we have specified, right? So in this process of tokenization, right, there are some characteristics, maybe we can say punctuation marks, they are discarded, right? So the words what we have, we broke that particular sentence into words, and those words are nothing but called as tokens, and the process is called as tokenization. So what do you understand by stemming? So these are all pre-processing steps, right? We do. So mapping a group of words to the same stem, right, is stemming. So I can write bunch of words with single stem word, right? I can write bunch of words. I can write it as connect. I can add connected. I can add connection. I can add connections, and also I can make it as connects. All these are removed and you are getting a single word connect, right? Root word is what is picked. Exactly, Ikshita, correct. So it's a process of reducing your word, whatever inflections are there to your word, right? You just map to the root word, such as mapping a group of words to the same stem, right? But we have something which is more efficient than stemming, lemmatization. So what is that? Why it is more important to do even lemmatization, right? We have to do lemmatization, right? So lemmatization is something which is like advanced way of approach to stemming. So it's a process of group together your different inflected forms of the word, so they can be analyzed as a single form, right? They can be analyzed as a single item. It's very much similar to your stemming, but it brings context to the words. Right? It links words the similar kind of meaning also to one word. So if I say, for example, adjustable, it what will the stemming do? It will do adjust. Formality, if I write, T-I-Y, sorry, T-Y, so it may map to formality, maybe, right? So if I have now formality like this, it may map to formal, airliner, it may map to A-I-R-L-I-N, right? This is what our stemming does. But here lemmatization, what it will do, it's very, very clever. Was is there, right? Better is there, will make us good. Was to be good. Meeting is there. It will put it as meeting only. It will not remove the ing because it is looking at the context of your context and changing your words accordingly. Right? That is the difference between lemmatization and stemming. Okay. What is bag of words model? What is bag of words model? BOW. If at all I just say that I'll take this textual data and I pass it to the algorithm, machine learning algorithm here, that way it will not work now. We need a way here to represent your text data for the machine learning algorithm. So this particular model will help us to achieve the required task. This is very, very understandable and to implement. It is a way of extracting features from the text for the use in your ML, machine learning algorithm. So first what we will do, we use the tokenized words, whatever tokenization you have performed, for each of the observation you take that, and then you find out the frequency of tokens, right? Then the frequency. So if I say, it's actually raining at my place now. It's going to rain today. This was my morning statement, assume. Then I say, today I'm not going outside. Okay, being weekend, what I do, anyway, it's raining now. I'm going to watch a movie. some premiere show or something like that. So now we are treating each sentence as a separate document. You all are aware of this. And we make the list of all the words from all the three documents, excluding your commas, etc., punctuation marks. So what it will become for me now? It is going to. Okay, I did not remove stop words. I'm just writing it as is. Today, if I would apply stop words, all these are gone, right? I'm not going already has come now. Outside. Okay, watch the what the is also not there. Premiere show. Right? The next step is to create the vectors. Vectors are something which will convert the text that can be used by the machine learning algorithm. If you take the first document, it is going to rain today, and we check the frequency of the words from the unique words here. Right? It. Right? In this document 1, I have it one time, is one time, going one time, to one time, rain one time, today one time. Right? These all are becoming zeros to you. Right? Then second document, all these are zeros. I am not outside. Right? I think going will come 1. Yes. Others are 0. And document 3, 0, 0. Okay, I'm going. Going would be 1. 1, 2 is there. All are zeros. And I have watch and premiere. So what is happening in this approach? Each word. Now, what is each word called as? It is called as a token. And it is also called as a gram. Right? Like you have 1 gram, 2 gram. That is bigram, unigram. Right? You are creating the vocabulary of 2 word pairs. So you call it as bigram. If you are creating 1 word, it is called as a gram. So the process of converting this text into numbers, is called as a vectorization. If at all you are performing it as in binary vectorization, it will be only ones and zeros. Right? So there are different ways to convert your text into vectors. Counting the number of times each word appears in the document. Right? So I can calculate the frequency that each word appears in the document out of all the words in the document. Right? This is nothing but your BOW, bag of words model. Right? Now we are coming to the next. This is, if at all we are having so many zeros, it is called as a sparse matrix. Okay. Yeah. What do you understand by TF-IDF? This is very, very important, right? TF-IDF. Term frequency inverse document frequency. It stands for term frequency inverse document frequency. We call it as a TF-IDF weight. So what is this process all about? This particular process is to evaluate or to understand how important a word is important in a document, right? In corpus. Right? So it's a statistical measure. It is used to evaluate how important a word is to a document and a collection of documents or a corpus. So the importance increases proportionally here to the number of times a word appears in the document, but it is offset by the frequency of the word in the corpus. So you give a score, you divide it now. TF you divide, DF you divide. So it's a scoring of the frequency of the word. It's nothing but the frequency score of the word in current document. Suppose in doc 1. Since every document is different in length, it is possible that a term would appear much more times. Maybe there is a chance that if someone writes a review of 300 words or 400 words, a same word would appear more number of times in the document. It would appear much more times in long documents, we can say, than shorter documents. So term frequency is often divided by the document length also. So number of times the term appeared, right, by total number of terms. We are doing a kind of normalization, I can say. Total number of terms in the doc. Right? Then we have IDF, that is inverse document frequency. It is the scoring of how rare the word is across all the documents. It is the scoring of how rare. It is a measure of how rare a term is. Rare the item. I wrote IDF, na? So that's why I'm writing it as rare the item. Right? The more the IDF score. Rare the item, more the IDF score. So we can also make it as log of, by its IDF, right? Inverse. So I'll get total number of documents by number of documents with that particular term. Right? So it is TF IDF score or TF IDF. Okay. Next. What is word to vec? What is word to vec? Yeah. So word to vec is a shallow and it's a two-layer neural network. So which is trained for, we can say, to reconstruct your linguistic context of words. It takes input as a large corpus of words and produces a vector space. typically of several hundred dimensions, with each unique word in the corpus, and that unique word is assigned to a corresponding vector in space. So word vectors are positioned in a vector space such that words which share common context, there will be common context in the corpus. They are located close to one another in the space. Right? It's very, very computationally, we can say that it's an effective model for learning word embeddings from raw text. So it's nothing but word2vec is a group of models which helps to derive relationship between a word and its contextual words. Right? So when you have something like source, the quick brown fox, let me write it down. So the source is like this, the quick brown fox jumps over a lazy dog. Right? The quick, the brown. Right? The training samples. Right? Then first training sample will be, they will train the quick, the brown. Second training sample will be quick, the quick, brown, quick, fox. Right? Third sample would be again the story. Brown the, brown quick, brown fox, right? Brown jumps. Right? Training sample. Next, when it comes to fox, this is over in the first sample, this is over in the second sample, third sample, or fourth sample with the fox. I can write fox, quick, fox, brown, fox, jumps, fox, over. Right? So if I go for a skip gram model, we take a center word and window of context, neighbor words, and we try to predict the context of the words out to have some same window size for that particular center word. So our model is going to define a probability definition, that is probability distribution, that probability of a word appearing in the context given a center word, and we are going to choose our vector representation to maximize the probability. That is what is happening here in skip grams. Because it is a group of models here, inside this word2vec, you have skip gram, you have continuous bag of words. So this is an example of a skip gram. How do you skip? So it is nothing but we take a center word. Now center word is what? This is a center word. If this is a center word, if this is a center word, if this is a center word, right? We get different training samples. We take and a window of neighboring words, context words, whatever are there, and we try to predict that particular context of words out to some window size. And that also we are doing it for each center word. So it is going to define one probability distribution. And whereas continuous bag of words, from the surrounding context of words, it will predict the target word. The cat sits on the, That is gone. Means it has to predict that my target word is maybe mad or something like that. It should predict. That is your continuous bag of words. Okay. So this is one thing. You have something called as document to vector, right? It is also called as a paragraph vector, right? So paragraph vector is documents to vector. So this is an extension for your word to vector. So what is happening in this word to vec model? The model is learning to predict a center word based on the context. So given a sentence, the cat sat on the table. So our continuous bag of models will learn to predict the word sat given a context word, the cat on a table. Right? Like a distributed memory model here, what happens? The main idea is randomly sample these consequent words from a paragraph and predict a center word here. Right? Predict a center word there from your randomly sampled set of words, right? The context words or the paragraph ID. So it's a little bit different. So we can just stop for word to word. Okay, so skipgram is nothing but unsupervised learning technique. Most related words to a target word. The reverse process of your continuous bag of words. Okay. So the features of your text corpus in NLP are nothing but you have word count, you have vector notation, you have parts of speech tagging, Boolean features, and dependency grammar. Right? Okay. Right. Now, if at all you want to understand topic modeling, what is topic modeling? How do I explain topic modeling? What is topic modeling? So topic modeling is a task of using unsupervised learning technique to extract your main topics that occur in the collection of documents. So topic modeling in the context of your NLP, it is described as the method of uncovering your hidden structure in a collection of your text. First thing is your dimensionality reduction here, right? So topic modeling is a form of dimensional reduction technique rather than representing the text in its feature space, like word, count word for every word in your space. It will represent the text in its topic. We'll just change it to topic. So how will I write the feature space here? I just say word, count that word, right? For every word in V. This is how we write actually. Instead of writing word, now what I'll write? the text. We can represent the text in its topic now. Like topic, weight of that particular topic. For topic in topics, means the total number of topics, whatever you have. This way you are working with is a form of dimensionality reduction. So rather than representing the text in its feature space, right, we are representing text in its topic space. So topic modeling can be compared to the clustering. As in case of clustering, the number of topics, like the number of clusters, is a hyperparameter there. So by doing the topic modeling, we build the clusters of the words rather than clusters of text. Right? A text is a mixture of all the topics, each having a certain weight and a form of tagging. That is also there here. So you have collection of documents, topic modeling is done, you get the topics, you cluster the words, you distribute the topics, and from the topics you calculate the frequency of words. If the document classification is assigning to a single category, to a text, topic modeling is assigning multiple tags to a text. It does multiple tagging. So a human expert can label resulting topics with human readable levels only. And it will use different ways to convert these weighted topics to set of tags. Just now I told you, you have your collection of documents. You will get topic models. From the topic model, you can get topics, right? In the topics, there's a chance that you can make into clusters. A cluster of words, and then you have a document. This document would hold some distribution of topics, right? And also you can get from one particular, you can get the frequency of words. This is what is happening entirely in topic modeling. So it's nothing but finding, or simply you can say that you can extract some topics in a document or set of documents to find some hidden structures in it, right? Okay, what is the difference between regular expression and regular grammar? What is the difference between regular expression and regular grammar? Regular grammar. So regular grammar is used to generate a regular language, and regular expression is used to represent a, you are representing it in a regular language. Representation is happening using regular expression. Generating is happening using a regular grammar. It's as simple as that. Okay. We have different types of, I should not say types actually, maybe we can say the steps, order of steps in natural language understanding. So natural language understanding is nothing but we are using to generate outputs in natural language from structured data. What are the order of steps in that? Order of steps in NLU. So you have signal processing, semantic analysis, pragmatics, and syntactic analysis. This order, right? Sorry. Signal processing, syntactic, semantic, and pragmatics. Right? So if you talk about signal processing here, it's a method where you enable a software to analyze, to modify, and to synthesize signals. In NLP, we can say that these are your sound or text signals also, right? Now, pragmatic analysis is nothing but information extraction from a bunch of docs, or we can say in the corpus, or from a given text. So when you go for pragmatic analysis, it is nothing but it is a set of linguistic tools or logical tools, right? It will enable us to get some meaning of the given structure, right? So when you do some syntax analysis, it is just syntactic analysis. It is a phase where we try to process your given text structure, and this process tries to draw some meaning from the text by comparing it to your the grammar rules or syntax. Right? Sentiment analysis, semantic analysis. The semantic is nothing but the process of understanding the meaning in the way how we humans understand and how we communicate. So it focuses on very, very larger parts of your data or processing than any other analysis techniques here. So this, you have something called as even sentiment analysis, right? It's also known as your emotional AI. So where you are trying to pull or detect the polarity of the text data, the opinion here. So majority you identify the text, extract it, you quantify it, right? Maybe you do it on whether it is a review, whether it is a survey response, or whether it is a social media opinion. Because the major applications of NLP are nothing but machine translation, speech recognition, sentiment analysis, text classification, right? So how we are getting our speech recognition applications here, our Alexa, Google Assistant, Siri, right? These are all your real-time applications of NLP, speech recognition. They are very, very common techniques, right? NER, whether it is sentiment analysis, whether it is text modeling, whether it is text summarization, right? All these are common techniques here. So with respect to this NLP, you have many components where you have, as I discussed, lexical analysis, syntactic analysis, semantic analysis, pragmatic analysis. All these are components, and we are able to do all this with respect to the tools which are available here, right? The tools, what we have like NLTK, PyTorch NLP, Open NLP. It's very, very easy for us to do all these things, right? Lexical analysis, as we discussed, like lemmatization and stemming, right? And to reduce the dimensionality of the data, we are using TF-IDF, word to vec, right? And many open source libraries are there, so this is making the concept of NLP very, very strong and very important, right? Okay, we'll stop here and please continue with the next session. Thank you all for joining the session. Thank you.